All right. Good morning, everyone. Welcome to the Embedded C into Prep live webinar. I'm really glad to see so many of you joining live today. Before we start, just quickly type in the chat your experience level 0 to 2 years, 2 to 5 years, or 5 plus years, and whether you are currently working or preparing for interviews. Let's make this session interactive. All right. First of all, thank you for taking time on a weekdays, uh, weekend morning to invest in your career because most engineers say, I want growth, I want better salary, I want to move to a product company, but very few could actually sit down and prepare in a structured way. So today's session is about structure, what you will get today. So in this session, I will show you what to prepare in a merit C, how deep you need to prepare, what companies actually test, and how to know whether you are interview ready or not. And we will also have a live C quiz to test your current level. So stay till the end, and this quiz will be very revealing actually. And one most important thing is this is not going to be just theory, just motivation, or just generic advice. This will be a practical and realistic. If you follow the roadmap properly, you will know exactly what should I do from tomorrow. All right. So first of all, let's talk about the roadmap, which we really need to basically go through whenever we are preparing for any interview. So even though we are experienced people, we are working in industry from 1 year, 5 years, 10 years, 15 years. But when it comes to preparing the fundamentals, we always lack there because in our day-to-day task, we don't focus much upon the fundamentals because we are very much comfortable in working in our projects, but when it comes to prepare for the interview, definitely the expectation is to have the your fundamentals ready. And that's why whenever somebody comes to us and they ask, like, they know C but they don't know like how much C they need to prepare for interview, like what exactly they need to prepare from C and how much level of depth they really need. So with respect to the merit series interview roadmap, so you should have very clear strong fundamental with respect to the C core concepts. Maybe it's volatile and then constant and then string, array, functions, pointers. Everything should be in the like depth level, not the surface level, because being an embedded system engineer, it is required for you to basically know the internals of each and everything, or we can say the each and every concepts of C programming, right? And then definitely you should have good understanding of memory and the pointers, because most of the people say like they lack somewhere in the pointer, they cannot solve the complex pointers questions basically. So before going for an interview, you should spend some time preparing for the pointers basically, right? And then because you are an embedded system engineer, so you should clearly see like how your C programs basically interact with the hardware, so you should have that level of understanding or thinking in your mind, right? And definitely you should have problem solving ability, because in an embedded system interviews, they don't expect you to write the program in the high level of DSA basically. They don't know, they don't want you to basically learn the advanced DSA backtracking dynamic programming. That's not at all needed basically. They want to check your logical thinking, like can you really think like how to write the programs for the basic problems, right? We'll talk about it, like what area to focus when you are preparing for embedded say interviews with respect to the programming, right? So so these are the core fundamentals which you should really focus upon. It's data type, stack versus heap, pointers. When it comes to pointer, single pointer, double pointer, function pointers, and not only knowing the concept on the surface level, you should also understand where the function pointers are really needed. So like we use function pointer in the callback functions in our embedded system projects, right? Or maybe if you are aware about Linux kernel device driver development, so in the device driver, in the FOB structure, we basically give the reference of the functions which we define in our driver as a function pointers, right? So we should also know the practical use of each and every concept of C fundamentals. Then only we will be able to explain in the interview in the right way, right? And then definitely array versus pointer difference. We should practice a lot of questions with respect to that. And structure and padding. This is the mostly asked question in the interview: structures and padding. So most of the people get confused whenever there is a complex problem given with respect to predicting the size of the structures. And then if you will ask them like what is the use of alignment, why we cannot go ahead without an alignment basically, right? And then bitwise operators, const, volatile, static, preprocessor macros, undefined behavior, memory layout of C program. Definitely it's an important, because we have to understand how our program will be loaded into the memory, what are the different sections will be there in the memory, and which variables or which content will go into which sections of the memory. So you should practice a lot of problems around memory layout of C program as well, so that you will have the deeper level of understanding of this concept, right? So these are the core fundamentals. And then definitely we are preparing for an embedded system interviews, irrespective your domain is automotive or your domain is firmware, bare metal, or anything. But if you're going for an embedded system interview, definitely the expectation will be at least you know C programming or C++ programming, depending upon your current job role basically, right? So these are the few topics which are embedded specific basically. You should know volatile keyword in embedded. So if you will ask what is the use of volatile, if you will simply say volatile is used to basically stop the compiler optimization, that is not going to help you out, because even the fresher will be replying in the same way, right? So you should know the internals of volatile, how exactly volatile stop the optimization, what is the actual use of volatile in your embedded system projects, right? And then memory mapped IO, how the memory is basically mapped in the memory. In case of IO devices, how you can read and write to the IO devices, what are the precautions you need to take whenever you're writing some data to the IO devices basically, right? Then of course bit manipulation, you already know in our hardwares we use bit manipulation a lot, right? So definitely in your interviews also there will be a lot of questions which will be asked from bit manipulations, right? And then ISR basics, you can ignore this part as of now, because you will be covering this part in RTOS or Linux kernel device driver, depending upon your role basically. And then of course Indianness of the system, you should be very clear about it. What is little Indian, what is big Indian, and you should also know how to write a program to predict a system on which your program is executing, whether this is a little Indian system or the big Indian systems, right? And then alignment and packing, which I already talked about, right? So we should know about this, right? So now the question is, this is the biggest question asked in an interview, like how much C programming is really needed, right? So the thing is, string. So first of all, like you don't need to practice basically on the lead code a lot of DSA problem. You don't need to solve 500 DSA problem just to target the good product companies like Qualcomm, Nvidia, AMD, Broadcom. You don't need that basically. So what you need is, you need to practice problems from these areas. Actually these are more than enough basically. If you will have good understanding of solving problems related to strings, like implementation of a string and then manipulating a string basically, so you will be able to uh, do a lot of programming. You will be able to solve a lot of programming questions related to string in the interview. And then of course array also, you should practice a lot of problem with respect to array, right? And then stack, queues, and then linked list. Definitely. So if somebody will ask you like what to prepare from the DSA, so linked list, stack, and queue, these are the three topics which you should focus whenever you are preparing for an embedded system interview. And in linked list, definitely create, insertion, deletion, traversal, and finding the basically middle node of a linked list, right? So these kind of questions you should basically expect in the interviews. Then of course bit manipulation, a lot of programs like clearing a bit, setting a bit, and then tolling a bit, right? So these kind of questions you should practice with respect to the bit manipulation. So the whole idea to cover this slide is, I don't recommend you to go through the lead code and solving 500 DSA problems just to prepare for the interviews. That will be totally wastage of time, until unless if you're targeting mang or fang based companies, let's say Google, Apple, Facebook, they can ask advanced DSA questions. But most of the time Nvidia, Qualcomm, and these company don't ask that, right? So now, okay, so this was about the roadmap. Now I have included a quiz of around 25 to 30 questions. So how this is going to work is, I'm going to show you these questions and I will give you 30 seconds to basically um, tell the answer. Basically you will need to type the answer in the chat, and then I will explain the answers that, or I will tell you the correct answer of this, right? And also I would request you, all of you, like don't spam the chat. Okay, use this chat only to give the answers or the things which I am asking. At the end of this session we are going to have a live Q&A session in which you can ask your queries, all right? So Let's start the quiz. We'll go one by one. And first of all, because this is our first quiz basically, so we have kept it very simple or beginner friendly basically. So it's very easy quiz which we have come up, right? So this is the beginner friendly quiz basically. All right. All right. So the correct answer of this is C, right? The reason is, like the P is pointing to array. So array is basically the first element, which is your 10, right? So when you do P plus plus, so it's a post increment operator, right? What does it mean? It means like first the operation will be executed, and before that it will take the value of P. Basically the value of P was 10, so 10 will be the correct answer. And then plus plus is the post increment operator, which will be changing the value of this pointer basically later stage, right? So the correct answer is 10. All right, so let's move to the next problem. All right. So the correct answer of this problem is C. So we use the volatile to basically prevent the compiler from optimizing away repeated reads to the same address. And also wherever we feel like any variable can be changed anytime by external environment, maybe some, let's say you can take example of some hardware status register basically, and it can be changed, it can change from the external environment. So better to basically create that variable as a volatile, so that every time we will be getting a fresh value instead of getting the inconsistent value of that particular variable, right? All right, comment the answer of this. All right, so answer A is the correct answer for this. One second. Yeah, so answer A is the correct answer for this. The reason is macro will expand in this way: 3 plus 2 cross 3 plus 2, right? So now, depending upon the precedence of your operator, basically, so this will become like this. So 3 plus 6 and then plus 2. So the answer will be 11, right? Let's move to the next problem. All right, so you have to find the bug which issue exists in this attempt to clear the bit 5 of the register basically. So the whole idea of we want to use this logic to basically clear the only the fifth bit of this register basically. So what is the issue in this code? All right, so the issue is you wanted to set the fifth, or basically you wanted to set the whole bit to 0, accept the bit 5, but it will perform the reverse of that basically. It will clear the uh, basically fifth bit and set the other bit basically. So this is the wrong code basically, and how we can fix that. So first of all, just understand what is happening here is you have doing this register star, so this will become star of reg, and then performing an operation with 1 left shift by 5, right? So what it will do is it will set the fifth bit and clear all other bits basically. But what we wanted is we wanted to clear the fifth bit and set the other bit. So how we can fix that is if you will change your statement like this: star reg AND operator, and then NOT operator of this. So now, in this case, what will happen is your fifth bit will be cleared and other bit will be set. And then when you will perform the AND operator, you will get the exact result of it. Right? Okay, so let's move to the next problem. Which section of memory holds uninitialized global variables in an embedded C program? So these are very simple questions we have kept considering this is the just a first quiz basically. In the next session, we'll have uh, difficult level of questions in the quiz. All right. So the correct answer of this is BSS section. The BSS basically block started by symbol section contain all uninitialized or zero initialized global and static variables which are zeroed at the startup, right? So this that's why uninitialized global variable will goes into the BSS section. Let's move to the next question. What happens if a local variable is declared as static inside a function? All right, yes, the correct answer is A basically, right? So this is the correct answer of the value is retained between multiple calls to that function. So declaring a local variable as static gives it its global lifetime while maintaining local scope, right? All right, before move to the next question, I just want to let you know we are starting a embedded system into prep bootcamp 3.0 from Monday, which is tomorrow. All right, so enrollment will be closing today. If you want to enroll for 3.0, you can basically, I'm just giving you an link, you can go through that. And we have kept the 20% discount open only for like after this webinar, we are going to close this discount. So if you have not enrolled for that, you can check this out. After this webinar we will be closing the discount, so you have to enroll it and the full price, and enrollment is going to be closed today. So as part of this bootcamp we are going to cover C, RTOS, kernel drivers, DSA, resume prep, mock interview. Everything will be covered in a structured way, right? Let's move to the next problem. Okay, so on a system 4 byte integer, what is the value of size of struct for the following? All right, so the correct answer is 8 because character A, even though it takes 1 byte, but after that, 3 padding bytes will be added to align your data correctly. So that is why it is going to take total 8 byte. 4 byte will comes 4 byte will be taken by character A, and then 4 byte will be taken by your integer variable B. So 8 is the correct answer. Right, now one more thing I want to add into this. So let's say if I am going to add short, means after integer b I'm going to add a short variable c, then what will be the size of this structure? All right, the size will be 12 because most of the people think like short variable will need an alignment of basically 2 byte. But the thing is, we also need to take care in structure in the tail padding. We call it tail padding. So tail padding will be basically depending upon the biggest data element which you have in your structure, basically, right? And the biggest data element you have in your structure is integer. So depending upon that, tail padding will be done. So 12 will be the actual size of this given structure, right? So let's move to the next problem. Yeah, you have to predict the output of unsigned integer x equals to 5 if x is greater than equals to minus 1, printf greater, else printf lesser. Right. A is the right answer for this basically. And the reason is when you give minus 1, so minus will be promoted to unsigned integer and the value of this will be 2 raised to power 32 minus 1. Right. So definitely this value will be greater than your x. Right. So the answer is lesser. Okay. What is the primary danger of using a naked inline function in an header file for an embedded project? So basically you have a variable which is, or sorry, you have an inline function defined in the header file and you are going to use in your embedded projects. So what will be the correct answer for this? So like the answer will be option B basically. And the reason is it can lead to the code bloat as the function body is copied to every call side. So maybe it's included in the header file, but the thing is you're going to use this function everywhere in your project. So wherever you're going to use this, so that definition will be expanded at the pre-processing stage. So because of that, there will be bloating in the code, right? So of course the size, binary size is going to be increased. All right. Now predict the output of the following: integer x equals to 10, y equals to 20, integer star const pointer equals to emphasis index star p equals to ptr equals to 30, and then print of the value of x. All right. So the value of this will be d basically. The reason is this is a constant pointer, but the value which is pointed by this pointer, that is not a constant. So definitely you can change the value of the pointer, right? So you have assigned the value 30 here, so the right answer will be 30, right? So like after, like before anything which comes before this star, so that tells you the value which is basically contained by your pointer, so that will define the properties of that. But anything which comes after this star, so which that will tell you the basically property of your pointer. So here you can see constant pointer, it means pointer is constant, means the pointer address cannot be changed basically, or the address which is going to be held by this pointer, that cannot be changed, but the value at that particular address can be changed, right? Let's move to the next problem. Which operator is used to toggle a specific bit in a register without affecting others? So this is the easiest question, right? So the correct answer is, uh, you all know, right? The correct answer is A, right? Let's move to the next problem. All right, many of you are pinging on the WhatsApp and they are telling like, can they join this boot camp in the same discount in next week? No, that will not be possible actually, because we are running the boot camp offers from last 1 week actually, so we will not be able to accommodate that actually. If you want, you can enroll it now itself. Typical use of a function pointer in an embedded drivers. Yeah, the correct answer is option D. So we use it a lot for defining our callback functions for asynchronous event like ISRs and the other cases in our embedded system based project. Callbacks certainly play an important roles in all of our embedded system project basically. Right. So you need to predict the output. You have given a main function and then character I is unsigned character I is basically initialized with the value of 255 and then you are adding 1 to this variable I and then you are printing the value of I. So what will be the correct value of this? Alright, so the correct value is 0 because the maximum size possible for this character I is 255 and this is an unsigned character. So once that overflow will happen with the maximum value, so it will move back to the value 0 basically, right? So A is the correct answer for this. Alright, now what is the result of 5 then right shift by value 1? What is the result of this? Alright, so the correct answer is 2. The reason is we are doing the right shift. So when you do the right shift, it means you are dividing this variable with 2 raised to the power n. Basically, n is 1 here, right? So 5 by 2. So this will give you the value 2, right? So 2 is the correct answer for this. Okay, which of this is a dangling pointer? A pointer initialized to null, a pointer that point to a memory location that has been freed, a pointer that was never initialized, a pointer that points to a constant value. Definitely the answer is B because dangling pointer means you are still referring to that memory location, but that memory is not a valid memory location basically. So that is called the dangling pointer, right? Okay, so now predict the output of this given problem. All right, the answer of this is D because like in this problem we have missed the break case, right? So until unless it will find the break statement, it will keep on printing, right? So it will print 1, 2 and default. Okay, what is a Little Indian architecture? Everybody must know this. All right, like the least significant bit is stored at the lowest memory address, right? So you have to find the bug. What happens when this macro is basically called? So the problem is you are basically using a macro, and in that macro you are basically passing this plus plus value, right? Now the thing is because x is going to be appear twice in the macro expansion, right? So plus plus value is evaluated twice if value is greater than 0, right? Which can lead to the incorrect result and the double increment, right? So that is a problem in this program. So option B is the right answer for this. How do you define a constant that should live in the flash memory instead of a RAM on most microcontroller? All right, so answer C is the correct answer for this. The reason is when you declare a variable with const, so compiler and linker basically typically plays global constant variable in the .ro data section or the text section, which resides in the flash basically. But it's all depend upon the implementation basically. But this is the most right answer I would say for this question. All right, you have to predict the output integer a equals to 5, b equals to 2, and then float c equals to a division by b. Printf, you're printing the value of c. All right, the right answer is basically b. The reason is c perform integer division when both operands are integer. So 5 divided by 2 equals to 2. Casting happens after the division, right? So 2 is the correct answer for this. So what is memory leak in C? We all know that, right? So A is the right answer of this because this is, I'm not going to spend time on this question. So when dynamically allocated memory is not released using free or some other API call given by your system, right? So failing to free memory means the application loses access to that block while it's still occupies the space, eventually leading to the exhaustions of your RAM, right? Which header file should be included to use fixed with integer types like uint32 underscore t? So we use these kinds of basically integer types a lot in our embedded system based project. So which header file is included for that? All right, so C is the right answer for this, right? C99 standard basically introduced this header file to provide you portable fixed width integer types. What is the purpose of linker script in an embedded project? All right, the answer of this is C, right? So to map code and data section to specific physical memory address. So basically, linker script is going to define the memory map of the target hardware, right, and direct the linker on where to place the binaries sections, right? So linker script will be used for that. All right, what is the output of this given program? All right, so the answer will be option number C. The reason is the comma operator evaluate x equals to 1, and after that you are having 0. So the overall value of this expression will be 0. So that is why else block will be executed and it will print the value b. Okay, so in an embedded system you have a hardware register at this particular address and this is updated by a DMA controller. So basically you have hardware register which is updated by some external environment, that is your DMA controller. Why is this flowing definition problematic? So you all know, right? Because I already mentioned if you see something is basically you are expecting to be updated by some external environment, maybe hardware, DMA controller, or input output devices. So it's better to use volatile here. So if you will use volatile with this variable, so that's perfectly fine, right? So you will stop all the optimization which can be done with this. Okay, what will be the output of flowing code involving pointers arithmetic? So you have to tell that. All right, the answer will be 30 because your pointer p is basically pointing to the first element of this array because you are initializing it with to the base address of this array, right? When you do uh, basically p plus plus, even though you are doing p plus plus, but that is post increment operator basically, so the effect of this plus plus will be in the next statement, right? So p plus 2, basically your pointer is moving to this location, right? And then you are printing this value, so of course the answer will be 30, right? On a 32-bit architecture with 4-byte alignment, what is the size of struct s? All right, yes, the size will be 12 basically. The reason is 4 byte for this, 4 byte for this, and then 4 byte for this. And as I mentioned, tail padding will be used here because the large data element which you have in this structure is integer b, so 3 byte will be added here. So the total size of this structure will be 12, right? Okay, what is the potential issue with this function intending to return a string? So what is the issue you see with this code? All right. The reason is you are returning the basically local variable, and you know that the scope of this local variable, or we can say the life of this local variable, will vanish once you return from this block, right? So this buffer pointer will behave like a dangling pointer. So what you can do is, so what is the best way to basically protect this or solve this issue? So can you guys comment? Yes, the answer is you can basically use static. So static is basically going to uh, maintain the value of this buffer address basically, right? Very good. Okay, so this was the simplest quiz we kept, this being this is a first session basically, so it was just a ramp up, we can say, right? Now you guys can ask any question if you have with respect to your career or related to boot camps or anything you can ask. Go ahead, please. You can type in the chat all your questions.